Okay, question 32, in my opinion, is actually just tedious. Okay, so they want you to have a current of 3 ampere flowing from the battery. So before this current has entered your circuit, they want the current output from the battery to be 3 ampere. So to get 3 ampere, you are applying the V equals to IL at the source. So if you apply V equals to IL at the source, the resistance here is your R effective. And because the question is suggesting to you that you are going to do some changes here, the R effective is not just 6 ohm, it's a question mark, you do not know. Okay, but by applying the V equals to IL at the source, you can deduce that your R effective has to be 4. So now your challenge is to ask yourself, how do you add a resistor here so that your effective resistance becomes 4 ohm? And the hint is that these two are already in series and is already giving an effective resistance of 6 ohm, 4 plus 2. So the only way to decrease a resistance is through a parallel connection. Okay, because if you use series connection again, it's going to increase the resistance further. Okay, it's already at 6 ohm, you do not want to increase it further, you want to reduce it. So in order to reduce it, they give you 4 options. So it's either you are going to connect it this way, okay? If not, you are connecting it this way. If not, you are going to connect it, oh sorry, this is a fuse, but it's either like this way. If not, this way. Okay, so your job is just to find out which connection and whether or not is it possible to get our effective of 4. Now the thing about this is that if you want to connect it this way, you have to put 4 ohm here so that the effective resistance here is 2 ohm, and then 2 ohm plus 2 ohm you get 4 ohm. Okay, if you try out A, B, C, no matter how you try, you cannot get an effective resistance of 4. The only option that will give you a effective resistance of 4 ohm is your option D, and you have to connect it this way. 12 ohm. Okay, so how do you prove that? First, you combine the 4 and 2 ohm because they are in series, so you got 6 ohm. Then you have this 12 ohm on top. Use your parallel connection effective resistance formula. You will find that eventually you get 4 ohm effective resistance by connecting it this way. Okay, so that's why I say that it is a very tedious question. We just need to try. Okay, question 33 is about your resistance. So what they are telling you is that the resistance is increasing with temperature. Okay, so that means as you turn it on for longer and longer duration, the tungsten is going to get heated up, and as it heats up, the resistance is going to be heated up. So if you look at this 4 graph, the y-axis is voltage, the x-axis is current. So what happens is that the gradient of this graph will be just the difference in y-axis over difference in x-axis, right? So if you have this understanding, you will realize that your gradient is actually your resistance. So you know that temperature is going to increase, right? So meaning that when the temperature increases, your resistance is going to increase, and in this case, resistance is represented by your gradient. So your gradient is going to increase. Okay, so if you look at A, B, C, D, you know that A is constant gradient, which is a no-no. You notice that for B is again constant here, you know that it is a no-no. You look at C, at the beginning, the gradient is pretty steep. and at the end the gradient actually becomes flat. So in C the gradient is decreasing, so you know that it's a no-no. And if you look at D, beginning is quite flat, at the end is quite steep, so you know the gradient is increasing. So therefore D is your answer. Okay, for your question 34, which one has the largest working resistance? So use the formula P equals to V squared over R. So if you make R the subject, you will get R equals to V squared over P. So since you have P, you have V, you can find out what is the resistance, just work it out. You will find the answer. What is the mistake here? I think it's quite obvious. The switch is on the neutral wire, which is wrong. Why? Because even now the switch is off. What happened is that this 240 volt, right? 240 volt, 240 volt, 240 volt, 240 volt, 240 volt. Even your load is at 240 volt when your switch is open. So imagine if you are doing some repair, your hand touch this, the 240 volt will flow through you and then kills you. So the mistake here is actually the switch here. So therefore your A. Okay? I think the rest of the option is quite obvious why it's wrong. So let's save the thing. Question 36. The reason why I put the star here is because I'm still having some doubt. So I will come back to it with a separate video on questions 36. Now the thing is that, let's go through it one by one. Option B, the object is attracted by a strong magnet. Now the thing is, if the object is just a soft iron, it is still going to be attracted by a strong bar magnet. So it is not a confirmation observation. So you know that B is wrong. Similarly, C, any magnetic material will be attracted by a magnet. So it is not a confirmation test whether or not this object is a magnet. Now the thing about this compass needle is that the compass needle is non-magnetic. So if you have a non-magnetic, not non-magnetic, if your compass needle is not a magnet, your compass needle can be just a, oh no, your compass needle is a magnet. Sorry, your compass needle is a magnet. So meaning that when this magnet points away from an object, it means that this magnet is reacting to a magnetic field from the object. And if the object is producing a magnetic field strong enough to affect the compass needle, which is a magnet, that means your object must also be a magnet. So therefore, I feel that A is also a possible answer. Okay, that's why I put the star here. Now, if you look at D, I also accept it. That's why my initial answer, I also state D. Now, D says that the object rotates before being attracted to a bar magnet. So what happened is that they are saying that now I have a bar magnet. This is my bar magnet. And I have an object. Now, what would cause the object to rotate? What would cause an object to rotate is a repulsive force. So imagine now my object is a magnet. Assume that it has a magnet. So if north-north, down here there will be a repulsion and this guy is going to fly to here. Because the south pole wants to get attracted to the north. So that's what this is saying. The object rotates before being attached to the magnet. So yes, this observation confirms that the object is a magnet. So D is correct. Okay, so the doubt is that why is A wrong? Because a compass needle is actually a magnet as well. And if you have an object here that has a magnetic field, and this magnetic field is strong enough to affect your magnet, it is also a confirmation observation. So let me find out from other physics teacher how they feel about this question, and I will come back to this. Okay. Question 37 is like I said, let me see. Okay, so you have a north, you have a south. So your compass needle is actually a magnet. So the north will point here, the south will point here. Okay, so what happens is that when the south is being turned clockwise, so this way. So what happens is that the south is going down. So what happens is that the compass needle will react to it and go this way. So as it continues, the thing is going this way. So meaning that your compass will go this way. So your compass is actually turning anti-clockwise. Okay. Okay. Question 38. Okay, what happened to the magnet? What happened is that using your right hand grip, right hand rule, you will notice that if the current is going up, the magnetic field is actually going anti-clockwise. So the magnetic field is going this way. So what happens is that your north will go here and your south will go here. So the magnet will rotate clockwise. Okay, it will be D. Okay, this one is you have to use your left hand rule. So use your left hand rule. Force, magnetic field, current. So the magnetic field is pointing into your paper because what you're seeing here is the butt of the arrow, 3D arrow. Electron is going this way means that the effective current is moving this way. Remember, direction of current is always opposite to the direction of electron. So that's why my current finger will point down. So you can see my thumb is pointing to the right. So that's why your answer is C. Okay. So this one, they tell you that when the magnet is going this way, you get this this reading. So now the magnet is being pulled back. So if going in is going to give you a positive induced current, when the magnet is being pulled out, the induced current must be negative. Okay, so you already know that A and B is wrong. Now the magnet is now being pulled back with greater speed, and you know that by Faraday's law, the amount of induced current is directly proportional to the rate of change of magnetic flux. So if this guy is going at a greater speed, there will be a higher rate of change. So therefore, your magnitude must be greater. So D is out. So C is correct. Okay? That's the end of paper 1.